agents, retrieval augmented generation, context windows, orchestration. This vocabulary creates a wall between the technology and the people who run the business. The terminology makes AI feel like a black box, alienating the very experts needed to make it function. To understand what is happening inside that box, look at this receiver. A large language model does one thing: text in, text out. It works like a highly trained mortgage specialist sitting alone at the end of an isolated telephone line. This remote specialist has years of professional knowledge, underwriting rules, interest rates, and regulations, but they suffer from total amnesia. They know nothing about the caller, they cannot press buttons on their end, and the moment the call ends, their memory wipes completely clean. If AI is a text-in, text-out system, a blind expert on a phone, then making it useful requires building a physical infrastructure to fix those specific limitations. We solve the amnesia before the call starts by handing the specialist a detailed client file. This file contains everything they need: who you are, what you need, and what a good outcome looks like. This transparent box represents the context window, while the file is the prompt. The box dictates how much the specialist can keep in mind. Fill it up, and new information is rejected. Feed the box vague instructions, and the expert is forced to guess. Vague intake packages guarantee useless advice. This makes the context window the primary bottleneck for quality in any AI system. Even with a full client file, the expert is still trapped on the phone. They cannot legally approve a loan, pull a credit report, or drive to inspect a property. We give them hands through tool calling. Instead of speaking in conversational paragraphs, the model outputs a rigidly formatted request, asking your system to take a specific action. Zor internal code executes the request. It runs the tool, generates the report, and feeds the resulting data back into the conversation as plain text. In regulated industries like banking, this setup ensures that every action runs through systems you already own, keeping every step within your existing audit trail. The next challenge is scale. The specific answer for a transaction might be hidden inside millions of historical loan files, far more than can fit inside that transparent context box. Retrieval Augmented Generation, or RAG, handles this by scanning the library and isolating the relevant paragraph before the call. Vector databases search for meaning, not just keywords, so a search for late payment surfaces documents about delinquency through underlying concepts. RAG acts as a precise filter, ensuring the specialist sees the exact data they need without drowning in the rest of the archive. When we combine the prompt, the tool calling, and the targeted search into a continuous, automated cycle, we create an agentic loop. The model requests a tool, the system runs it, the results go back in, and the model evaluates the progress. It decides whether to request another tool or if the work is done. The pulse completes the circle as needed. This cycle relies on strict formatting, clear input and output rules that define exactly how information moves. It is the digital equivalent of a standardized paper form in a traditional bank. Ultimately, an agent is a text generation model wrapped inside an automated feedback loop of strict paperwork. Understanding this loop leads to a critical business rule: only add autonomy if it pays for itself. Every system sits on this ladder. A single prompt is predictable and stable. A hard-coded workflow adds complexity but remains testable. The agentic loop offers the most power, but at the cost of predictability and control. In enterprise AI, architectural complexity represents an operational cost that must be justified by the results. The agentic loop is governed by schemas, the rigid definitions that tell the system what your tools and data actually mean. This layout shows why precision is mandatory. If the business defines delinquency poorly, the AI will produce catastrophic errors. A simple balance and an available balance are two different financial realities that require two different behaviors. Technologists build the infrastructure, but only subject matter experts provide the business logic. They define the terminology the system uses to make decisions. The system's success depends entirely on the precise language provided by those human experts, the exact definitions of the business, down to the final comma.